In this video recording, I'm going to go over balancing redox reactions in basic solution and using practice exercise 3 as an example. So if we're in basic solution, remember all that means is that you have an excess of hydroxide ions, not hydronium. So hydroxide will come into play. If a reaction occurs in basic solution, one can balance it as if it occurred in acidic solution. Once it's balanced, add hydroxide to each side to neutralize the H+. So you're going to see that you'll make water, and if you have water on both sides, you might have to cancel that out. Let's go ahead and try this with practice exercise 3. So for practice exercise 3, we're going to follow the exact same steps that we did in practice exercise 2. Hopefully you work through that a few times and you feel comfortable. This one, because we have oxygen in all of the reactions and products, we have a couple more steps to follow, which is good for this review. We'll do everything the same, and at the very end, once we double check that the entire reaction is balanced, we will indeed convert from acidic to basic solution. Depending on the textbook or the online homework platform that you're using, there are different ways to approach this. I like to add the hydroxide at the very end, so you're only doing it once. Okay, so to write our half reactions, I'm going to link chromium. We'll do this one first. CrOH3. And you want to give yourself lots of space on both sides. CrO4 2-. Balance all non-O and H first. That would be chromium. I have one chromium on the left, one chromium on the right. Step 2, balance oxygen by adding water. 4 O's on the right, 3 O's on the left. So I do indeed need to add one H2O to the left-hand side. Now I see that I have 3, and 1 is 4, and 4 oxygens on the right. Now I'm going to balance H with H+. 3 hydrogens, 2 hydrogens is 5. None on the left, so I'm going to add 5H+ on the right. Yes, we are in basic solution. We're going to convert that H+ to hydroxide at the very last step. Now we're going to balance in terms of charge. 0 on the left, -2, and +5 gives me +3 on the right-hand side. I need a charge on the left and the right to be the same. So I'm going to add 3 electrons, remembering that electrons come in as negative charges. So now I have a charge of 0 on both sides. Let's double check, make sure we did that properly. 1 chromium, 1 chromium. 3 and 1 is 4 oxygens, 4 oxygens. 3 and 2 is 5 H's, 5 H's. Charge of 0, +5, -2, -3, -5 is 0. I definitely encourage you to double check after each half reaction that you've balanced it properly, because that's the best time to catch mistakes. And again, mistakes are fine to make as long as you catch them. Now we're going to link the 2 chlorine atoms. So we have ClO- going to Cl2. Step 1, balance all non-O and H atoms. That would be chlorine. 2 chlorines on the right, 1 on the left, at a coefficient of 2. Now I have 2 chlorines on both sides. Balance oxygen by adding water. 2 O's on the left. So I need 2 waters on the right. And again, the goal there is to balance our oxygens. H2O. Now balance H by adding H+. I've got 4 H's on the right, so I need to add 4 H+ on the left. So let's see, 2 chlorines, 2 chlorines, 2 oxygens, 2 oxygens, 4 H's, 4 H's. Now let's balance in terms of charge. I have +4, -2, gives me overall +2. On the right-hand side, I have a charge of 0. Add 2 electrons to the left-hand side. And let's say you make a mistake. Okay, let's say you're adding the electrons, you think, 2 to the right. Then we would count and see -2 is +2 and -2 the same. It's not, it's like, oh, mistake, no big deal. Cross it out. Add the electrons to the left-hand side. And now I see that -4 and +4 is indeed 0, and so we are indeed balanced. Okay, now we need to cancel our electrons. I see I have 3 electrons being lost in my oxidation. They're on the right. My reduction half reaction, I have 2 being gained. Least common multiple of 3 and 2 is 6. So I have to multiply the top by 2 to have 6 electrons lost, and the bottom by 3. I'm going to go ahead and do this with black ink so it'll be a little easier to see. 2, and I usually just write really large on top versus rewriting the entire half reaction, because I worry if I rewrite it again I might make a mistake. It also takes a lot more time, but do whatever is best for you. 3 times 4 is 12. 3 times 2 is 6. 3 times 2 is 6. Okay, now I'm going to add these together. And again, it was these electrons that we needed to cancel, which 6 electrons on both sides. Now I have 2CrOH3 plus 2H2O. And the order at which you list the reactants does not matter. You just need to make sure that all of the reactants stay on the left and all of the products stay on the right. Forming 2CrO4 2 minus plus 10H plus 3Cl2 plus 6H2O, and we're going to see that we can indeed cancel some things. I see I have 10H plus on the left. 12H plus on the left, 10 on the right. So I can cancel 10 from both sides, and I'm left with 2H plus. And I have waters. I have 2 on the left, 6 on the right. So this will make 4. Okay. So now that we have a balanced overall equation, we want to get rid of that H plus because we're in basic solution. So I'm balanced right now, so if I add the same exact ions to both sides of the reaction, I will indeed still be balanced. A little more space here. I'm going to then add 2 hydroxides on the left and 2 hydroxides on the right. Because if I do the same thing to both sides, we're still balanced. 2H plus and 2H minus, as you all know, that makes 2H2O. Now I can see I've got 2 H2Os and 4 H2Os, so I can cancel 2 from both sides. So I'm left with 2 H2Os on the right. Now let's go ahead and rewrite this for one final time, and then we'll double check that we are indeed correctly balanced. So 2CrOH3 plus, it's like all of that got canceled out, 6Cl0 minus, aqueous, forming 2CrO4, 2 minus aqueous, plus 2 hydroxides, plus 3Cl2, plus 2H2O. Okay, so let's make sure that we are indeed balanced. 2 chromiums, 6 chlorines. 3 times 2 is 6 chlorines. Now let's check our hydrogens. 3 times 2 is 6 H's. 2 hydrogens. 2 times 2 is 4. 2 and 4 is 6 hydrogens. And lastly, oxygens. I've got 3 oxygens here. 3 times 2 is 6. I'm going to write this down. So for oxygen, I have 3 times 2 is 6, plus 6 is 12. On the right-hand side, 2 times 4 is 8, and 2 is indeed 12. Lastly, the charge. We want to make sure that we are indeed balanced in terms of charge. Right-hand side, pretty easy, minus 6, because I got 6 -1 ions. On the right-hand side, 2 times -2 is -4. 2 hydroxides, that's -2, overall -6. We are indeed balanced. I would encourage you, after watching this video, go ahead and get a blank piece of paper and try this again on your own.